Hello, this is Chip Westby. I'm the sales manager for Benchmark Measurement Solutions. We're formerly known as Turner Designs Hydrocarbon Instruments. Today we're talking about produced water treatment systems. This can be our Section 1 discussion for disposal well injection monitoring. In an oil production environment, the water generated in the production can be discharged into a local ocean if the water quality and regulations from the local government allow for that. But in many cases, the water is discharged into a specially drilled well. Sometimes these are called SWDs or saltwater disposal well. The water from that well is injected into a special formation, subterranean formation that is not connected to the original oil production. The formation will have very specific size of particles and oil concentrations that can be allowed, and a certain high pressure of water is required to push the water into those wells. The water treatment for injection into a disposed well can be quite different depending on the location. In the drawing that we have today, we're just looking at a couple of storage tanks. Because the water is disposed into a well permanently and not discharged into an ocean, the quality of the water, the oil concentration, and things like that aren't as important as when they're returned to an environment like the ocean. To achieve the approximately 1500 psi, a very high pressure pump, a specially designed pump, is used to inject that water. The water from the production environment is permanently disposed into this well and into the formation. The formation has certain qualities of water required for its operation, meaning that the concentration of oil, the droplet size of the oil, the concentration of solids, the particle size of the solids are all part of the equation of how well this formation can accept the water. If those values are exceeded, especially for an extended period of time, maintenance might be needed from this well, either mechanically to clean out the solids or the oil, or chemically with acids and caustics in order to remove the oil from the formation and from the injection wells. All of these are high cost, and any of these things will reduce the ability of the oil company to inject water into the formation. Also, any oil that is injected into that formation is oil that's lost because this formation is not connected to the oil production. So all this is permanently disposed. When we look at that high pressure pump and the water treatment system delivering the water to the pump, there's a couple of solutions that can help the oil production companies prevent or reduce the amount of maintenance costs and reduce the amount of oil loss into these wells. There are two different technologies of water monitoring systems. One is an ultrasonic probe that will measure the oil and solid particles in that water and will indicate immediately if those change. If there's a significant change, the operators can choose to redirect the flow of the water into a tank for further treatment, recirculate, or have some other chemicals or other treatment systems added. At the same time, there are more advanced technologies for water analysis available that are visual particle analyzers that can actually measure and differentiate the size and shape, concentration of the droplets. So you can know the concentration of oil and solids separately and the particle sizes of the oils and solids separately. Therefore, the operators will know what could be causing damage to the well and therefore have a better treatment option available to them. The ultrasonic probes, the TD2500, can be an ideal solution due to its operation at very high pressures and high temperatures. It has self-cleaning characteristics because of the ultrasonic sensor technology, plus being a non-optical and ultrasonic measurement technology, the probe can see through most coatings that are on that. Because it's a probe and injected directly into the process, the installation is quite low cost. The particle analyzer also works at extremely high pressures. It is an offline device, but it does have self-cleaning characteristics as well, and it will confirm that the measurement is as appropriate through validation methods. But both cases, the operators will have significantly more information and ability to optimize and control their water injection than without these systems. Thank you for your time today. If you'd like to learn any more details about these systems, please contact us. Again, I'm Chip Westaby, Sales Manager for Benchmark Measurement Solutions, formerly known as Turner Design Hydrocarbon Instruments. We can be reached at www.oilandwatermonitors.com and at sales@oilandwatermonitors.com. Thank you.